Newton's first law is one of three laws of motion first formulated by Sir Isaac Newton in the 17th century. The first law pertains to objects which have balanced forces on them, where the forces are either non-existent, there aren't any forces, or there are forces but they are balanced and there is no net, no resultant force, no unbalanced force on that object. And Newton's first law says, and there's a little definition of it here, or a statement of it, every object will continue to move at a constant velocity or remain at rest unless it is acted on by an unbalanced force or a net or resultant force. So we're talking about objects with balanced forces, no net forces, no resultant forces. And it effectively says that if that is the case, there will be no change in the object's velocity. Now, no change in velocity means it will either keep going at a constant velocity or remain at rest, which effectively is a constant velocity of 0. Now, don't forget that velocity includes both speed and the object's stated direction. So the velocity of the object can change if the speed changes or the direction changes, which goes back to what we're talking about with acceleration in a circle, with the direction changing but the speed being constant, and therefore the velocity changing and the object being subject to a net force. So if there is no net force, the object will not change its speed or it won't change its direction either. So let's have a look at a few examples of objects that are obeying Newton's first law. I mean, the simplest one is an object in deep space with no forces on it at all. You know, there is zero force. And if there's zero force, obviously there's going to be zero change in velocity, so the object is just going to sit there. Or if it's already moving, if it's moving, say, with a velocity v in this direction, there's nothing to change that object's velocity, there's nothing to accelerate it, there's no force. So that object will just carry on moving in a constant velocity with no force on it at all. But what if we have this sort of situation over here where we have an object with forces on it? Now let's say these forces are the same, so we've got the same force here and here. If the object is stationary, it's fairly obvious that those forces will balance and cancel each other out, this one pulling this way and this one pulling this way, so that the object will not move. But slightly more tricky to comprehend is if the object already has a velocity. So if it's moving at a constant velocity but it has balanced forces on it. So let's have a look at that situation where it's obviously been speeded up somehow, it's been accelerated to that velocity, but then the acceleration stops and the object starts moving at a constant velocity. Hopefully you can see that this force is pulling to the left by the same amount or the same magnitude that this force is pulling to the right. So even though the object is moving, these two forces still cancel each other out, and therefore they are unable to change the object's velocity. So the object will still continue to move even though the forces on it are there, because they are balanced. And therefore there is no unbalanced force, no net force, and therefore no change in velocity. So if it's stationary or at rest, or if it's moving with a constant velocity, these balanced forces will mean that it will continue to do that. And here's a real life example of that. There's a car and it's moving at a constant speed. So let's say it's moving at a velocity of 20 meters per second to the right, and it has two horizontal forces on it. So we have the forward force from the engine, and we have the drag force from the air resistance and the tyres against the road, etc. If that object is obeying Newton's first law, then those forces must be balanced. There is no unbalanced force, no resultant force, and therefore with those two forces balanced, the object will continue to move at a constant velocity of 20 meters per second to the right. It cannot change its velocity, and therefore it is obeying Newton's first law. Newton's first law was originally called the Law of Inertia, and the Law of Inertia relates to the concept of inertia, and effectively the inertia is a measure of how how reluctant an object is to change its velocity, which is obviously what Newton's first law talks about. So, and that relates to the mass of the object. Inertia and mass are very, very closely linked together. So imagine two objects. You have a very small light object, low mass, and then you have a very small, very large, heavy, high mass object. And let's say that they're acted on by an unbalanced force of the same magnitude. Now, clearly, I hope you can see that the heavy object will be much more difficult to get moving or to change its velocity to accelerate it if you put that same force on it compared to a light object. So the heavy object, we say, has more inertia, and this one obviously has less inertia, because with the heavy object, with the same force on it, it's going to get going a lot more slowly. It's going to accelerate at a much slower rate because it has more reluctance, if you like, to change its velocity because of its inertia, which links to its mass. Okay, so sometimes Newton's first law is called the law of inertia because it relates to an object wanting to carry on the way it's going, reluctant to change its velocity. So without that unbalanced force on it, that inertia will either hold it where it is or it'll carry it on at a constant velocity the same way as it was going.